Hello students, today we are going to discuss the second question of your exercise 1.1, and the question show that any positive odd integer of the form 6q plus 1, 6q plus 3 and 6q plus 5 where q is some integer, means we have to show that how many positive odd integers are there. All the positive odd integers are in the form of 6q plus 1, 6q plus 3 and 6q plus 5 where q is some kind of integer. So by solving this question we easily understand that how a positive odd integer could be in the form of 6q plus 1, 6q plus 3 and 6q plus 5, which is unknown, that we are going to discuss with the solution. So let's start this solution. So the thing is that this solution is to be solved by using Euclid's division lemma. Means you have to solve this question, you have to use this Euclid's division lemma. So let us see how it can be solved. So you just see here, you have to start like this. Let us consider a positive odd integer as a on dividing a by b. Means there is a positive odd integer a and b which are divided by each other, just like this. A is division by b. So where q be the quotient and r be the remainder, that you have to understand. So as we know that Euclid's division lemma is like this: a is equals to bq plus r, where r is greater than or equals to 0 and smaller than b. Means the value of r, I always say that in Euclid's division lemma r is very important. Now let's just take like this. As we see in the question says the positive odd integer should be 6q plus 1, 6q plus 3 and 6q plus 5. So it means this is the important thing, that is take b as 6. On putting b is equal to 6 in equation 1, we get like this. So a is equals to 6q plus r. So where r is greater than or equals to 0, and in place of b we just put 6. So let's start the first thing. It means that the value of r must be like this: 0, 1, 2, 3, 4, 5. Why? Because r is smaller than 6, means the value should be r is equals to 0, r is equals to 1, r is equals to 2, r is equals to 3, like that. So one by one step we used to solve like this. So let's start is first, if r is equals to 0, so that means a is equals to 6q plus 0, means the value of r will be 0. So 6q, so 6q is divided by 2, so 6q is an even number, so that is not at all proved. So let us take the next one is, if r is equals to 1, so that will be a is equals to 6q plus 1. It is not divisible by 2, not divisible by 2, hence 6q plus 1 is odd. Similarly, go for the next thing. If r is equals to 2, so that will be 6, a is equals to 6q plus 2. So from this thing we just take 2 as common. We took 2 as a common. So what does it mean? It means that this number is divisible by 2. If it is divisible by 2, definitely this will be the even number. So again we write 6q plus 2 is an even number. This is also not countable. Now again we go for the next thing, that is r is equals to 3. So when r is equals to 3, a is equals to 6q plus 3, and it is not divisible by 2 because we are not getting anything in common. So 6q plus 3 is an odd. Similarly, like this we continuously are going. R is equals to 4, then a is equals to 6q plus 4. Then again we can take the common 2 from it. So again this will be 3q plus 2 and 2. So this 2 is the common thing, so which means it is divisible by 2. Again 6q plus 4 is even. Then again go for this one, r is equals to 5, then a is equals to 6q plus 5, which is not divisible by 2. Then 6q plus 5 is odd. So from this three thing, 1, 2 and 3, from this three thing we understand the a is an positive odd integer which is in the form of what? 6q plus 1, 6q plus 3 and 6q plus 5. Similarly, there are so many examples in your book that you have to solve by this method. The steps should be like this. You have to go for these steps. Thank you.